I'm Greg Jones, Engine Builder Editor, and today we have an engine oil Q&A, and I'm joined by Ken Tyger of PennGrade1. Ken is a 20-year veteran in the industry. He's been with PennGrade since 2001 and has been in the technical services realm since 2005 for PennGrade. He's a certified tribologist, and needless to say, he knows a lot about motor oil. Ken, good morning and welcome.
Well, good morning, Greg. Thank you very much for having me. Just a quick hello to all my DA colleagues, all of our distributors, dealers, and handlers of our great products, but really a very hearty hello to all of our loyal customers. Thank you very much for having me, and I've looked forward to this event for some time. We'll give them a good show.
Absolutely. Well, Ken, thanks again for being here and giving us some of your time to answer questions, which is what this event is all about today. So I know there's a lot of you on this webinar this morning. I'm sure that you've noticed you're basically in like a quiet mode. You're muted and we can't see you guys, but we want this to be interactive. That doesn't mean we don't want to hear your questions. We certainly do. And in order to do that, all you're going to have to do is go to the bottom of your Zoom screen where there's a Q&A tab. You'll just click on that, and we ask you to just type in your questions, and we'll just kind of go through them as they come in. So please don't be shy. Ken's here to answer those, so please start typing whenever you guys have questions, and we'll get to them. But Ken, I want to start with you first. A couple questions from me. I know most of your role, along with your colleague Nick Dixon, you guys do a lot of travel. You're out on the road for much of the year, and obviously with the current situation, that's certainly changed. Can you talk a little bit about what your last few months have been like, and how it's affected PennGrade too?
Yeah, it's been tough. Around Daytona 500, which is really the unofficial start of the racing season, you start to get that itch to get out and start racing. The engines are being put in the cars, and there was just none of that this year. And with the ease of these restrictions, you're starting to see a little bit more activity. You're starting to see more of the sales of PennGrade1 increase, and that's, again, just an indication that people are starting to pull out their classic vintage legacy street rod muscle cars, and of course the racing. I'm glad you mentioned my friend and colleague Nick Dixon. I've long been called the face of PennGrade1, but the true heart and soul of this product line is Nick Dixon. So I just want to say hello to my friend and colleague. Wish he was here joining me, as he often is, but with the restrictions in place, it is what it is. So you're absolutely right. Nick and I would normally be out on the road answering questions about this great product and all of our products in general. We know the product line as good as anybody. We came from that side of the fence when the Brad Penn Finished Lubricants division was sold to and acquired by the DA Lubricant Company in 2015. Nick and I came along. So obviously any questions directed to us are generally about the green oil and its unique characteristics and performance.
Sure. No, I'm sure many of us miss seeing you guys out on the road. I know you were here at Babcock's Media's headquarters back in February, which seems like a lifetime ago, but I'm glad we got that in when we did. And to your point, glad to see that racing's starting to get back underway and people are starting to get their cars back out, and all that's opening up. Ken, just another quick question. I know many of us know that, those of us who do know, PennGrade has a pretty storied history, but for those of us who don't, do you mind kind of just running through a quick history lesson of how PennGrade1 came to be?
Sure. In the late 1960s, the original green oil was rolled out as the Kendall GT1 High Performance Oil. And for many years, it flew under that banner until around 1997, when the Kendall company pulled up stakes, if you will, and left the Bradford, Pennsylvania area to join the ConocoPhillips family. Around 2001, it was decided to create the Brad Penn Finished Lubricants division. Of course, the original green oil fell under that moniker and flew under that banner for many years. In 2015, again, the Brad Penn Finished Lubricants division was sold to and acquired by the DA Lubricant Company out of Lebanon, Indiana. Now, when you think about the original green oil formulations, those formulations went with that acquisition. Okay, so the owner of DA Lubricant Company, Mike Prodiger, owns those original formulations. So when you think the original green oil, those are in fact still blended and processed at DA headquarters in Lebanon, Indiana. The green oil lives, ladies and gentlemen, and it is sold by the DA Lubricant Company under the name PennGrade1 High Performance. Yes, the bottle was redesigned. Yes, the name was changed. But what's inside that bottle is that same multi-generational lubricant that your father used, your grandfather used for decades. There is a reason why this lubricant has been around for over half a century.
Perfect. Thank you, Ken. Just a quick reminder, if anyone's joined us just a couple minutes ago here, I'm here with Ken Tyger of PennGrade1. I'm Gregg Jones, the editor of Engine Builder magazine, and we want to hear your questions. So if you've got questions, at the bottom of your screen is a Q&A button. You'll just click on that to type in your question, and we'll kind of get to them as they come in. So, so please keep asking, and we'll get through. Ken, we've got our first question here from Guy Snyder. Guy says that he's a user and a dealer of your product, and he loves it. His question is, why are engine builders and the local dirt late model guys using 20W50 or W anything? A lot of the guys he talks to preheat their engines and don't start them until 200 plus degrees. Then they go out and their temperature gauge goes up to 300 plus degrees, and they come back to the pits at the end of the race with little or no oil pressure. So he's asking, why not run an SAE 50 and be done with it? And what is the viscosity of 20W50 and SAE 50 at 300 plus degrees?
Well, there's a lot there, Greg. So many different directions I can go with that. But let me start with the multi-grade versus the monograde. A lot of people assume that the W in a 20W50 or 10W30 indicates weight. It has nothing to do with weight. It actually stands for winter, and it identifies that oil as being a multi-grade lubricant, one that is better used in cold ambient temperature startup conditions. Some of the benefits a racer would use, or at least consider benefits to use a multi-grade are: one, fuel economy benefits, horsepower benefits. Now, Greg, you and I have been around racing a long time. There aren't too many racers that we've come across, certainly that I've come across in the 20 years that I've been associated with high performance racing, that place more of a value on fuel economy over the ultimate protection of his or her engine. That's why individuals use PennGrade1 regardless of viscosity, the protection and the performance value. Regarding, I think the last part of your question was operating temperature and the viscosity. You know, theoretically, a 2050 and a straight monograde or linear viscosity 50 weight would be the same viscosity under operating temperature. But when you break it down even further, the 20W50 would actually be a little bit more viscous under operating temperature. Now that's taken into account virgin material, free of contaminants. You're talking about the significant difference between a multi-grade and a monograde, and that is the polymer, the VII, that a multi-grade possesses that a monograde or linear viscosity does not. So theoretically, the 20W50 would be heavier under operating temperature. But the longer you keep that multi-grade in service, the more the mechanical shear that you can expect to have, the more, even though the chemistry that we use is very shear stable, the longer you keep it in service, the more shearing you will have. So eventually it's going to get to a point where even that 20W50 will have a lesser viscosity under operating temperature than the straight monograde 50 weight. If that is something that I would be more than happy to follow up with Guy on another call if he would prefer. But that is a great question, Guy, and thank you so much for asking. I hope I've answered it in some satisfaction for you.
Yeah, excellent, Ken, thank you. And Guy, thank you for that question. We've got another question from Dwayne Jennings. Dwayne says that many engine manufacturers specify full synthetic oil, and there are many opinions and practices for engine break-in. Many rebuilders that he's experienced want break-in oil, or at least a conventional oil, for the first X number of hours or X number of miles. And he's heard that full synthetic oil may be too slippery to allow proper ring seating. Is there any truth to that?
Absolute truth, and that is a fantastic question. Let me talk about the difference between synthetic oil versus conventional mineral-based, at least in regards to engine building. Any qualified engine builder worth their salt will tell you that they expect some wear to occur during that initial run-in phase. The whole premise of engine building, successful engine building, is to properly seat the rings. It's all about conformity. By running a synthetic oil as a quote-unquote break-in oil, it will create a very labristic characteristic, not allowing those rings to seat. Again, any qualified engine builder will expect some supportive wear to occur. That is the reason why many break-in oils have controlled levels of anti-wear, not more. If you have too much anti-wear, it could actually interfere with ring conformity. So any engine builder, or at least one that's contemplating the run-in of a green oil, a green engine, never use a lubricant that is of synthetic nature or one that has a synthetic component, and B, use one that has controlled levels of anti-wear, not a product that is absolutely saturated, because you're talking about two scenarios that would literally interfere with ring conformity. Our break-in oil, the PennGrade1 SA30 break-in oil, was designed to be 100% conventional and contain controlled levels of anti-wear. Again, it was specifically designed and tailored to help facilitate ring seating, not work against it. The typical time frame that we recommend with our break-in oil can be 30 minutes dyno session, or anywhere between 150 to 200 road-driven miles. Now, we would obviously recommend the removal of the break-in oil once the engine builder has done a successful leak down test or a compression test to validate ring conformity. We've known engine builders to run our break-in oil up to 500 miles, even up to 750 miles, just for that warm and fuzzy feeling to know that once they have seated the rings, they're good to go. It's our advice then to drain the break-in oil immediately and then replace with whatever quote-unquote running oil it is they plan on utilizing after the fact. Harken back to the old school days when the old school engine builders were literally trying to run in steel cast iron rings. Their first lubricant selection was always the non-detergent 30 weight. The reason for that is quite simple. Without the added detergency, you would have a lot of varnish buildup via internal combustion. And it was actually the varnish buildup that would help facilitate ring seating in those steel cast iron rings. Today's more flexible chromoly rings, not only is it good to have a little bit of anti-wear, again, at controlled levels, but also a solid detergency package, which again is offered via the PennGrade1 SA30 break-in oil. So I hope I've answered his question.
No, that was excellent. Ken, before we move away from Dwayne, he had a second part to his question, and another participant named Eric had a similar question regarding zinc and how it affects the camshaft. So Dwayne asks, there's a lot of talk regarding zinc levels and older engine designs struggling with wear, specifically the camshaft going flat with older style flat tappet lifters.
Yes.
Whether it's a remanufactured engine or one that is still factory sealed, the answer seems to be spending money on, engine oil, a Kinematic zinc additive, or even a diesel oil for a gas engine. What is the truth? What is the folklore in regard to high zinc levels?
Okay, I'm going to try to answer that in the order you gave me, because again, there was a lot there. Let me first discuss the utilization of diesel oil in a spark ignited or gasoline fueled engine. Most individuals have done their homework, and they've realized that today's oils have very strict oil specifications. Today's oils are formulated with better fuel economy and better emissions in mind. On the emission standpoint, you've seen a reduction in the amount of anti-wear, specifically the phosphorus. In a ZDDP package, a PCMO package, the ZDDP, the zinc dialkyl dithialphosphate, the anti-wear package, once you have reduced the amount of phosphorus, you could have a certain level of zinc. In a ZDD package, the phosphorus is roughly 90% of the zinc content. So when you reduce the zinc, you reduce the phosphorus, all done to protect and extend the life of catalytic converters. That is not music to the ears of many flat tappet cam owners, or at least those systems that employ the flat tappet cam. So the pre-1975 pre-catalytic converter classic vintage legacy car owners, they don't want to hear about the reduction in anti-wear chemistry. They want more. And to give you an example, a modern licensed oil, you're looking at a typical 800 parts per million of zinc, 760 ppm or parts per million of phosphorus. The PennGrade1 high performance oils will afford you a typical 1,500 parts per million of zinc and around 1,400 parts per million of phosphorus. So you're almost doubling the amount. Again, the classic vintage legacy historic muscle car owners don't want to hear about protecting the lowering of the ZDDP package or the anti-wear package to protect their catalytic converter because they don't have one. All right. So again, can you repeat the first part of that question just so I can make sure I cover it?
Yeah, he was just talking about camshaft wear with the flat tappet lifters. And then he just wanted to know about, what was kind of the truth versus the folklore of high zinc levels.
Okay.
And its effect.
Okay. So again, it's all about wear protection, and there's so many different ways that I could spin this off. PennGrade1 high performance oils are certainly known for their unique characteristics. A naturally high viscosity index, a natural metal wetting characteristic, an affinity, if you will, to metal surfaces, a tenacious clingability that is simply unparalleled, in the lubricant world. Couple that with the enhanced levels of zinc phos chemistry, and you have a product that is specifically designed and tailored for the protection of all the valve train componentry, the lifters, the wrist pins, the main and rod bearings, and especially the flat tappet and or roller cam, whichever you employ. When you're known throughout the industry as being the flat tappet roller cam oil, that speaks volumes, Greg, okay? And it literally sells itself. Words like pride, passion, pedigree, legacy, heritage, all best describe PennGrade1 high performance. But me personally, my most favorite is protection. And it's a protection value that is simply unparalleled because of the unique Pennsylvania grade base cut that's been used in this product over half a century.
Excellent. Well, Dwayne, thank you for the question. And Eric also had a question pretty similar. So thank you guys for those questions. Todd asked a question, since we're on the topic of zinc, he's asking, what is the approximate ppm level of ZDDP in PennGrade1 20W50?
Yes, okay. Again, whether it's one of our mono grades or our multi-grades, you're still afforded the same level of zinc and phosphorus chemistry, your ZDDP or anywhere package. The PennGrade1 high performance oils possess a typical 1,500 parts per million of zinc, a typical 1,400 parts per million of phosphorus. Again, that constitutes your ZDDP or anti-wear package.
Perfect. All right. Ken, we've got an attendee asking if there's a specific recommended oil weight depending on engine clearance. You know, if engine clearance is X, is your oil weight Y? Is there some kind of ratio there or anything correlated between those two?
You know, after 20 years, I generally adhere to three main criteria when it comes to viscosity selection. Obviously, the main and rod bearing clearance is absolutely critical and should always be considered. The anticipated ambient temperature operation is always critical. Is this a year-round driver? Is this primarily used for racing or cruising, if you will? There's a lot that goes into the ambient temperature concerns and when and where you're actually using the application. And last but not least is whatever the OEM, the original equipment manufacturer and or your engine builder recommend as the most suitable viscosity selection for his or her vehicle. I'm often asked two questions. Number one, how often should I change the oil in my particular application, and what viscosity should I run? You know, just to piggyback on what I just said on the viscosity, those that own classic, vintage, legacy muscle car engines, I'm talking original stock equipment, you have to remember that the bearing clearances in those engines were literally designed for the viscosity grades available in the 1950s, 1960s, 1970s, etc. So that's why almost universally, a lot of those end users prefer either a straight weight mono grade oil, which by the way is often recommended if you are driving your vehicle in what we consider the best ambient temperature environment, literally between 60 and 100 degrees Fahrenheit. Remember, the W in a multi-grade oil stands for winter, and it identifies that oil as being best suited for cold ambient temperature startup conditions. So really at any operating, specifically cold startups below 60 degrees Fahrenheit, it may be more advantageous to run a multi-grade. And that's why many end users, particularly classic car owners, will literally run a multi-grade oil year round. And certainly multi-grade oils have been around since the 1950s. So that's why many of those end users prefer the 1030, the 1040, the 2050. To my knowledge, our 2050 still to this day is by far our most popular classic vintage legacy muscle car street rod viscosity today. As far as racers, it really is dependent. That's when you get into your more unique bearing clearances, and obviously the looser the bearing clearance, the type of fuel that you're running plays a big factor in the viscosity. There's just so much to consider when it comes to viscosity selection. I hope that somebody does ask about drain interval later on. Again, I could just talk about some of these things all day. I mean, it's just how involved some of these topics are. But again, I hope I've answered his question satisfactorily.
Yeah, no, that was great, Ken. And yeah, I'm sure we'll get to some interval questions here shortly. You know, obviously this all interplays with one another, so we appreciate your advice. Ken, we've got Paul asking a question about two different cars that he owns. One is a 1988 Chevy 5.7 liter that calls for a 10W30, and the other is a 1999 Chevy 5.7 liter that calls for a 5W30. However, he's got some leftover 10W40 oil, and he's curious if he's able to use that in those two vehicles, specifically for summer months.
Yeah, absolutely. As a matter of fact, I'm very old school mentality minded, and I like running a heavier, more viscous oil, you know, in those warmer ambient temperature months. You got to remember, in your summer driving, you're doing a lot of stop and go, a lot of idling, which is not only difficult on the hardware, but on the oil as well. And certainly in Chevrolet engines, and I'm assuming these are stock engines, Chevrolet was one of those OEMs that was very consistent in their ambient temperature viscosity recommendations. At any operating, and I believe it was above 40 degrees Fahrenheit, they recommended either a straight 30 weight or their preferred multi-grades, which were really 10W30 and 10W40 respectively. So again, the warmer the ambient climate, the more stop and go driving, the more idling that you're doing, which is almost parallel to summer driving, the more viscous the material you should probably run. So to answer his question, absolutely 10W40 would be, in my opinion, the ideal viscosity to run in those warmer months.
Perfect. Thanks, Ken. And Paul, thanks for that question. Ken, we have a Kevin McFadden. He's asking about his toy car that he's got. It's a stock 1970 GTO that he usually puts about 800 to 1,000 miles per year on, street use with synthetic oil. His first question is it worth using synthetic in this car? He uses synthetic in everything, even the lawnmower. 2, how frequently would you recommend changing the oil? The temperature when the car is used is between 40 and 100 degrees.
Okay. You got to weigh your pros and cons with synthetic versus conventional. Now, many people, many end users utilize synthetic oils because they do offer better volatility. They tend to last longer. You have less evaporation or boil off. So the oil will allow you for longer service or longer longevity. Synthetic oils do a wonderful job with high temperature stability, and they do a phenomenal job with low temperature fluidity or pumpability on those cold start days. Now, some of the drawbacks with synthetic oils is that they can be very expensive, sometimes 2 to 3 times as much as a good quality conventional mineral-based oil. But my biggest knock against modern day synthetic oils is that they're very light and lubricating in their very nature, which means when you run an engine for whatever duration, you get it back to the garage and you shut down that motor, that oil lacks the clingability. The synthetic lubricant lacks that clingability and will literally drain down into your pan. Now, when you go out and turn that key for the very first time, now I'm talking cold engine start, turning that key for the very first time, where almost 70% of engine wear can actually occur. If you don't have that oil that's clinging and staying put like a good quality conventional mineral-based oil does, especially the PennGrade1 high performance, which it's known for, you put your parts in what's known as that boundary regime or that metal-to-metal contact. You know, you're talking about engine wear that can literally change surface geometry of the component, shortening engine life. I don't want anybody to go through that. So again, you got to weigh your pros and cons. Now, if you're talking a 1970 application, you got to remember back in 1970, there was no such thing as synthetic oil, at least mass produced and made available in a spark ignited or gasoline fueled vehicle. Those vehicles, those engines in particular, were literally born and bred on conventional mineral base stock. Now, I've had many people ask, you know, well, or comment on, you know, we love the fact that your monograde PennGrade1 high performance oils are 100% conventional, but we've also noticed that your multi-grades are, or carry the name partial synthetic. They're absolutely right. That isn't anything that we've done recently. About 13 years ago, when the product was known as the Brad Penn PennGrade1 high performance oil, the decision was made to make the multi-grades partial synthetics. The synthetic component in our PennGrade1 high performance oils is actually less than 10%. And it was only incorporated to give the end user the best of both worlds. Yes, you're getting some of the good characteristics that a synthetic oil offers, like high temperature stability, but it was never done and it was never incorporated at the expense of the remaining Pennsylvania grade base cut. All those unique characteristics I mentioned earlier, tenacious clingability, natural metal wetting characteristic, the affinity, if you will, to metal surfaces is still there. So just keep that in mind. And again, that was just a terrific question, and I hope I've answered his question properly.
Yeah, no, that was great, Ken. Kevin, thanks for that question. Ken, we've got a question from Russ Paniton. Hopefully I said that correct. He's asking about the importance of total base number, or TBN, for oil that's used in a streetcar engine, and also how you interpret NOAC volatility between the different grades of oil. Russ has a 66 Chevelle with an LS9 engine that sits most of the winter, so he believes that a higher TBN oil may provide more protection. You know, what are your thoughts on that?
Again, today's oils have very strict oil specifications, of which, you know, when you think about NOAC volatility, one of those specifications is really the increased resistance to volatility. You know, that evaporation, or that oil, you're talking about the actual molecules, the oil molecules that are evaporating and boiling off. The higher the volatility of any given oil, the greater the reduction in fuel economy, the reduction in performance. You're going to have increased engine deposits. The NOAC volatility, to my knowledge, with even the licensed API-SN oils, the percent weight loss allowable is 15. ILSAT GF5, or resource conserving oils, again shares that same 15% limit. I think the GM Dexos 1 fluids of today have set a much tighter percent weight loss, and that's at 12. You know, harken back to the older API, or the older obsolete SJ category, just to give you an example of the NOAC volatility today versus one of yesterday. The SJ was right around 22%. So there's been that much of a difference. But again, the newer oils today have all been designed with that lesser NOAC volatility limit. It's all about, again, the oil molecules evaporating and boiling off. The more issues you have. I want to go back, and thank you very much for that question. That was fantastic, and I hope I've answered it properly. But I want to go back earlier to one of the questions. This may lead into what Paul was asking. Earlier you mentioned about how often should they change the oil, and I think you actually referred to 800 miles to 1,000 miles of driving before the car is literally put away or stored. And what I typically recommend, you know, with PennGrade1 high performance, if it's just a street-driven vehicle, we still adhere to the 3,000-mile oil drain, or once a year, whichever comes first. Now, if I had to put a label on the PennGrade1, at least in relationship to an API service category, I would venture to say right now you're right around an API SJ with enhanced levels of anti-wear. Now, why is that important? Because even back in the API SA days, the zinc and specifically the phosphorus content was right around 1,200 parts per million. So you take the PennGrade1 anti-wear package today, which is even enhanced above that, 1,500 parts per million of zinc, 1,400 ppm of phosphorus. In relationship to the drain interval, again, every 3,000 miles or once a year. Now, many classic car owners adhere to that once a year drain cycle. But in many instances, they will literally drive the car all spring and summer, put the car away for the winter, and then in the following spring, when the ambient climate is more conducive to driving on a continuous basis, they'll pull the car out and they'll say, oh, I better change my oil. Where all they've literally done is leave all those harmful byproducts of internal combustion that they produced over the spring and summer. The acids, the soot, the varnish, the moisture, that is literally all left sitting in that engine over those winter months when you're leaving the engine sit idle, or what we consider static. If that's the case, and if you are under that once a year drain interval and only putting 1,000 miles on your vehicle throughout the year, always get into the habit of changing the oil and filter prior to any anticipated lengthy storage period. Change the oil and filter, take the car around the block for a few minutes, allowing that oil to get up to operating temperature. Then get it back to the garage, shut it down, and leave it alone. And that way you are assuring that the engine will sit with fresh oil in the block, essentially void of any harmful contaminants. The talk or the question about alkalinity, that is essentially the base number, the alkalinity, or what's in there, the formulation to help combat the acidic byproducts, the sulfuric acid, the nitric acid that is literally produced via internal combustion. So obviously a product that has a good base number will have plenty of reserve alkalinity to combat that. One last thing, I've had many individuals, Greg, tell me, you know, Ken, I change my oil religiously every 3,000 miles. But when I push them on the subject, they eventually fess up and say, well, you know, Ken, it does take me 3 or 4 years to hit that number. And all that suggests to me is that they are literally storing their vehicle every year with more and more of that acidic byproduct sitting in that engine. And for the overall longevity and better maintenance of that engine, get into that habit of changing the oil once a year or 3,000 miles, whichever comes first.
Perfect. And Ken, that was actually pretty timely. We had a question come in from someone asking about, you know, the fact that their car sits for a full year, you know, and what they should be doing. So that was perfect. All right. We got a oh, sorry.
Go ahead, Greg. I was just going to add, they're coming to me as I'm talking. And just to go back, one of the original questions was about, I think you made mention of additives. In my opinion, one of the worst things that you can do is add an aftermarket additive to an already blended, already formulated lubricant. Several reasons for that. When you add an additive, not only do you risk disrupting that perfect formulation balance, but now you've literally changed the identity of the oil. You have to remember that that blend is a perfect balance of the right levels or amounts of anti-wear, detergency, and all other additives, and the right amount of base oil. It's the perfect balance. So when you add that aftermarket additive, you certainly can disrupt that balance. And more often or not, one of the more popular additives, aftermarket additives, is zinc. That extra zinc that you've added can actually disassociate from that formulation and create more harmful acids that are just going to be left sitting in that engine. If the bottom line is, if you have to rely on an additive, any type of additive, to change some aspect of your oil's performance, guess what? You're using the wrong oil. Everything you need is self-contained in that PennGrade1 high performance oil. Please don't add or consider adding additives. It is absolutely not necessary.
Excellent. Thank you. Ken, we got a question from Mike Graybill. He's just curious if you're familiar with a product called Lubricheck.
I am not. I am not. But again, if this is something I would love to, obviously, I learn something new every day. So if this is something that I could follow up with him, I would be more than happy to. So thank you for that. And I apologize. I simply don't know, but I would like to. So.
Yeah, Mike, I'm not familiar with it myself. I haven't heard of it. So if you personally know a little bit more, please feel free to type it into the question. And like Ken said, he can get back to you at a later time.
No, absolutely.
All right. We have Dwight Bodler. He's asking about what you would suggest as an oil change on a bracket drag race engine for alcohol or racing gas conditions.
Alcohol or racing gas. Well, obviously, the longer you keep, and as great as our product is, the PennGrade1 high performance oils that's separating from the alcohol, the longer you keep that in service, the more pronounced that fuel dilution could ultimately be. So with bracket racing, and Greg, you know, I'm sure you've been around bracket racing, very, very difficult. Again, not only the engine, the hardware, if you will, but of the oil as well. As thermally stable as our product is, the excellent film strength and shear stability that it exhibits in every application, you're talking about a fuel source that could eventually have an adverse effect on the viscosity the longer you keep that in service. So just keep that in mind. The one thing that I want him to always remember is the one surefire way to determine oil viability or its useful life is via oil analysis. Now, not only does oil analysis provide a nice snapshot of the hardware at any given time, but also of the health of the oil at any given time. So whatever the price is, $8, $10, $12 for a kit to simply send in a sample, have what is known as a conditional analysis performed, they send you back the results. That would give you a great idea of the condition of the oil at any given time. So bracket racing and PennGrade1 has been hand in hand for many, many years, as far as I can remember. And many bracket racers do prefer PennGrade1 because of simply the demands that are placed on the oil and how well PennGrade1 does. So thank you for that question. That was great.
Yeah, perfect. Ken, moving right along, we have a question from Hank Coburn. Hank says, aloha and good morning. I'm not sure if he's in Hawaii or not. I'm a little jealous if he is. But he's got a question about PennGrade1 oil is historically or primarily been formulated for racing and hot street cars, or does it have the appropriate additive package for modern day vehicles as well?
That is a great question. Well, aloha, my friend. Thank you very much for joining us. Absolutely a great question. We are asked often, can I use PennGrade1 high performance oil in my post-1975 vehicle? And the reason I single out post-1975, we all know that's when catalytic converters were first mandated. Now, all should know, at least those that are considering running PennGrade1 high performance oil, because again, the one reason people do, many end users do, is because of the enhanced levels of anti-wear chemistry. In comparison to a modern day licensed oil, which has seen almost half of its anti-wear reduced simply to protect and extend the life of catalytic converters. We proverbially take the high road when it comes to recommending PennGrade1 in modern applications. It's not the zinc that can become detrimental to that sensitive catalyst within a catalytic converter. The catalyst, which could be platinum, palladium, rhodium, it's actually the phosphorus that can volatilize and essentially poison the catalyst, eventually getting to a point where your catalyst is not performing as designed. It's essentially useless. So we've had many end users ask, and we take the high road and say, because of the higher levels of phosphorus, PennGrade1 is typically not recommended for any modern vehicle equipped with sensitive emission systems. And yes, that would include O2 sensors. Now, on the flip side of that coin, hearing that caveat, they still run PennGrade1 anyways. Now, and again, the only reason is the higher levels of anti-wear. As long as they adhere to that more frequent, carefully selected interval every 3,000 miles or once a year, generally most people don't have issue. They, in particularly, don't have issue if they're not burning any oil. That's allowing that to get back into the catalytic converter. We know of many an end user that uses PennGrade1 high performance oils in even late model applications that have never had an issue with their catalytic converter. But at the very least, we have to express the caveat to say that the anti-wear levels are so high that it could become detrimental to the health of the catalytic converter in general, okay? So again, great question, my friend. I hope I've answered you. I can tell you what many people do, but I'd rather not. That ultimately it's your decision, but you should be aware of the consequences if you are burning any oil, because eventually it will affect the cat. So,
yeah, perfect, Ken. Hank, thanks again for that question. Ken, we've got a question from an attendee asking about extreme pressure, or EP. They say that they've heard it mentioned a lot with gear lubricants, but hasn't heard it very much for motor oils. Is that a factor with motor oils or not?
Well, certainly any time that you can protect components is always a plus. In particular with PennGrade1, we use an anti-wear. We use the ZDDP package, anti-wear package, zinc and phosphorus. I've seen competitor products throw everything in from, graphite, molybdenum disulfide, MOS2. There's a bevy of EP or extreme pressure additives or components that you can select. PennGrade1 does not incorporate those solid fillers, if you will. Again, it's all about the perfect balance of the right base oil and the right levels of additives. Our anti-wear additives are zinc and phosphorus. Again, it's what you decide to use and whatever the OEM, or at least in this case, the oil manufacturer decides is best as their high performance package. We simply get by with the zinc and the phos, and it has proven itself for decades.
Perfect. Ken, we've got someone named Charles Gavard asking, again, back to the camshaft and flat tappet issue from earlier. Does super finish eliminate the need of camshaft break-in? And if not, is there any impact on oil choice?
I wouldn't think the oil choice would be as significant as the actual surface. Gregg, I'm just not qualified or know enough about that to answer that question. Obviously, I appreciate the question, and it's something that I could certainly look into and provide him with an answer. When it comes to that type of hardware question, I can only theorize and guess, and I just don't want to shortchange him on that. I can tell you that with any particular surface, and after 20 years, you've heard about so many different surfaces being used, and I can tell you that for the most part, PennGrade1 has no adverse effect. That tenacious clingability and that natural metal wetting characteristics that the product exhibits seems to adhere to any particular surface. So again, are there surfaces out there that the PennGrade1 just doesn't adhere to? like the old school hardware, that's left to be known. But really, from what I've seen and the shows that I've done and the travels, myself and my colleague Nick Dixon, we simply cannot tell you that there isn't a surface out there that PennGrade1 can't be used with. So again, think about the product being known as the flat tappet roller cam oil. We didn't come up with that. That was something that was used by our end users that obviously we love to hear and have since adopted. The flat tappet roller cam oil, period.
Yeah. Well, thanks. And Charles, thanks for the question. If you want any more info on that, Ken's happy to circle back with you at a later point.
Absolutely. Thank you for the question. Great question.
Curtis Owen is an engine builder who specializes in air-cooled VW engines. Mm-hmm. He says that oil type and viscosity is always a big argument. Yes. He prefers PennGrade SAE 30 for break-in and PennGrade multigrade oil for continued operation. However, some guys think that they can get away with diesel 15W40. So he's asking how the ZDD package and other detergents and additives in PennGrade compare or excel.
Well, again, most people that use diesel engines and spark ignited or service-related engines, they don't do so because they're diesel oils. They do so because they know diesel oils contain higher levels of anti-wear chemistry. Even the very latest CK4 offerings of today possess a typical 1,200 parts per million of zinc. Now, in comparison, and I'm talking commercial grade compression ignited engines, the very latest API commercial category CK4, 1,200 parts per million of zinc. In comparison to the API SN Plus for spark ignited or service related engines, gasoline fueled engines, you're at 800 parts per million of zinc. So again, they're not using the oil because it's diesel. They're using it because they know they still possess higher levels of anti-wear chemistry. Are they okay to use that? Certainly. But they have to keep in mind that even though diesel oils and regular gasoline, spark ignited or service related oils share the same anatomy, they are very different and are designed for the needs of both the diesel engine and the gasoline powered engine. So they are different animals. Now let's talk about air-cooled engines. Air-cooled engines place an extraordinary demand upon an engine oil. Air-cooled engines create hot spots that the longer the oil is exposed to, the more pronounced the varnish condition that could occur, and certainly a more accelerated oxidation process. Using conventional mineral-based oils in air-cooled engines would only equate to a more frequent, carefully selected interval, in my opinion. And that is a sacrifice any air-cooled engine owner will make, given the performance and the protection of PennGrade1. Anything on an air-cooled nature, from Corvair, Porsche, Volkswagen, have long used PennGrade1 high performance oil because of its thermal stability and its shear stability. Not to mention that tenacious clingability. Those older air-cooled engines that almost to the unit incorporate a flat tappet cam. So not only are you getting that thermally stable, very shear stable lubricant, but the high levels of zinc phos chemistry. And again, as long as you maintain that more frequent, carefully selected interval, it will do a phenomenal job for you. I've listed a number of OEM, original equipment manufacturer vehicles that have long enjoyed PennGrade1's performance and protection. So absolute great question, and thank you very much for asking.
Yeah, no, perfect. Ken, Mike Graybill from earlier, who asked about the Lubricheck, he mentions that that is an oil tester, and it's been on the market for a few years, and it tests the oil for depletion of the additive package as one of its functions.
Sure.
Just to just to let you know.
No. Yeah, and I appreciate that, and it just dawned on me now that after hearing that he was simply sharing or asking my advice on oil analysis and maybe an oil analysis facility in general. There are a lot of good oil analysis facilities out there. Even harkening back to the Brad Penn days where we used a third-party entity, we still utilize a third-party entity. And I would encourage anybody, any end user, to get involved with oil analysis, and even to a point where if they just want to send in a virgin sample, PennGrade1, please send that to whomever you wish. I encourage anybody to have our oil tested, whatever oil you want tested, just so you can confirm, the viscosity, the kinematic viscosity at 40 and 100 C. Check for glycol or coolant contamination. Check for moisture contamination. Check the multi-source. The multi-source really defines that the specific additive package is present and functioning, and certainly any wear metals that would occur. All, again, paints a very nice picture for you of the health of the engine and the oil at any given time. So I have my preferred oil analysis facilities, but again, do your research. And if you have questions, if you want to reach out to me afterwards or any of my great DA colleagues after the fact, we can certainly shed some light on the good facilities that would be great at performing conditional analysis and providing you that sample data. It really is an invaluable source for, again, the overall longevity and better maintenance of your engine.
That was great. Yeah, we had a couple attendees asking about oil labs and getting it tested. So, yeah. Perfect. Ken, we have an Ed Lowe asking about his 604 crate Ford race engine that he runs E85 gas in. And he usually busts lifters when it's cold. So he's curious if there's a solution that you see for him there.
Okay. Let me first address E85 or alcohol fuel. The newer engine oils today, and I'm talking the newest licensed oils, have all been designed with better rust protection and emulsion retention. Phase separation was also critical with the development of modern oils to run in conjunction with E85. E85 fuels are hygroscopic in nature, which means they have a very nasty habit of collecting and holding moisture. When you run a product like the PennGrade1 high performance oil that literally clings and adheres to the surface, you always have that sheen, that film that never leaves the components. Now that's an ideal setting for someone that literally leaves their engine sit for weeks to months at a time. Again, remember what I said earlier about going out and starting up that engine for the first time, cold start, where almost 70% of engine wear occurs. You're always protected. When you utilize PennGrade1, you're always protected from what is known as that dry start scenario. Now, couple that with the hygroscopic nature of the E85 fuel, which you're already producing moisture via internal combustion. It's one of those byproducts that's produced just by running an engine. But when you utilize a fuel source that is, again, hygroscopic in nature, you're just producing more and more moisture that's going to be left sitting in the engine. So I can only guess, maybe it was poor metallurgy, maybe the E85 fuel was left in the crankcase over the winter months. Again, that's one of those situations, especially when you run E85, you should always get into the habit of changing the oil, run the fuel source down to nil, put in enough regular high octane fuel just to do a proper oil change. and then change your oil and filter. What happens with that hydroscopic nature of the E85, it can literally cause gelling, that gelling effect to occur, and that may have had an influence, a negative influence on the viscosity of the PennGrade1 if you were having some deformation or product or component degradation from the fuel and the oil mixture because it just simply gelled. Again, I'm just theorizing, guessing at this point, but if I had to, it's either a result of poor metallurgy, poor component, or an adverse effect from the E85 being used. So.
Perfect. All right, well, and thank you for that question. I just want to let people know we're about at the hour mark here. So we appreciate everyone sticking with us, and Ken's going to keep answering questions here. However, we are recording this session. So if for whatever reason you do need to drop off, don't feel badly. If you asked a question that we haven't got to yet, we'll try to do that, and you'll be able to watch this session at a later point. But we are going to continue. Ken, we got another Ford question here since we just touched base on that. Mike asks what your opinion on viscosity is in terms of using it with a modular-based Ford engine. Also with the lighter reciprocating weight, does that have any impact on the type of oil, the synthetic mineral-based viscosity, and so on?
Again, I would ask that he consider the OEM, the original equipment manufacturer, recommended viscosity for that given engine. I look at the three criteria before I even settle on a viscosity recommendation. Again, main and rod bearing clearance, ambient temperature operation, and again, whatever the OEM and or engine builder recommend. So really, my answer to that question is simply that. I look at the criteria first, and to make sure that in this particular instance, does the vehicle possess sensitive emission systems that could be negatively affected by the anti-wear package in the PennGrade1. A lot to consider there. I hope I've answered his question, but again, that really is one that I would rely heavily on the OEM recommendation.
Perfect. Mike, thanks for that question. Ken, Art has asked about people who heat their oil after a weekend of drag racing using methanol fuel to boil off the methanol that is in the oil. Is this practice okay or not recommended?
No. Please don't do that. We've certainly heard of many end users, rather than use fresh virgin oil, they will literally drain their oil, find themselves a heat induction plate, and literally try to cook off the methanol, which right around 165 Fahrenheit, you can do. I certainly don't recommend doing that. None of my colleagues would recommend doing that. It's essentially a small bomb at that point, and it's a very dangerous practice. And I certainly don't want anybody to get hurt. I would much rather you use fresh virgin oil than try to extend the use, or what really, in all sense of purposes, extending your oil drain just for the sake of doing so, just because you can. Is it okay? In my opinion, no. I would much rather you be safe than risk that. And again, protecting the engine and all the components is one thing. Protecting yourself is another, and that's much more important to me. So I'd rather you not do that. Okay.
Yeah. Well, Art, thanks for the question, and yeah, keep yourself safe. So take Ken's advice there. We have Mike Santoro asking about low-speed pre-ignition, LSPI, which has been shown to be caused by high calcium levels in the oil, from what he's heard. Do you publish the additive content in PennGrade oils?
Other than the typical properties that are already listed, Again, a typical 1,500 parts per million of zinc, 1,400 ppm of phosphorus. We do not list out our detergency package, typical properties, just to say that we do use, I call it a three-headed monster of calcium, magnesium, and sodium. It's a phenomenal detergency package, and it's been used in PennGrade1 for decades. Low-speed pre-ignition is the premature ignition of the air-fuel mixture prior to the spark-ignited emission that's supposed to occur. The modern licensed oils, specifically the API, SM, the SN, and now today's SM Plus, have all been designed to address LSPI. When you talk about an older legacy PennGrade1 formulation, obviously those formulations have not been designed with low-speed pre-ignition in mind. So if that is an issue for you, remember the modern licensed oils have all been designed to address low-speed pre-ignition, not the older chemistry PennGrade1 high performance. A different animal with a different agenda or a different utilization in mind.
Sure. Yep. All right, Mike, thanks for that question. Ken, I'm going to back us up a second because we had another question related to that TBN question from earlier. And we have Stefan who's asking why it's not important to concentrate on only one part of an oil specification. Should we pick one number and focus on that for a specific engine?
I'm not quite sure what he's asking there. I mean, in relationship to typical values or properties, if he's referencing, and please follow up if I'm wrong, if he's referencing, why we only list zinc and phosphorus, simply put, it was the one typical property that we were often asked. And it just got to a point where we said, you know what, we're going to make this very simple. We're going to cut down on hundreds of emails and phone calls because, again, it's the one inquiry that was often asked of all of us at Brad Penn and now PennGrade1. How much zinc and phosphorus is in your oil? So again, that's the only reason why we list those two. But if I'm missing your question, please follow up because I'd like to get it answered for you. But thank you for the question.
Yeah. All right, Stefan, let us know if there's anything more that we missed there, and we'll be happy to circle back to it. We got another question. Ken, you were talking about detergency in oils. We got a question about why the trend seems to be going to non-detergent racing oils. This person assumes it's for anti-foaming, but it seems like a step backward. Are you seeing that same trend?
I've seen and heard that. Racers are a funny bunch, and they're going to use what everybody else uses. There's a lot of word of mouth. When I think non-detergent oil, I literally envision an uninhibited, unadditized base oil. And for whatever reason, the frictional drag, the reduction of additives, maybe there's a cost involved there. They can't expect any significant or pronounced service life with an uninhibited, unadditized oil. So that's always something to keep in mind. For whatever reason they're choosing to run a non-detergent oil, that's their prerogative. But I would always cite on something that will contain those byproducts of internal combustion with the detergency package. Again, the soot, the varnish, the moisture. That's why all those additional additives are part of that package. You have nothing to combat those harmful byproducts of internal combustion running an uninhibited, unadditized oil. It is simply a base oil at that specific viscosity. Kinematic vis at 40 and 100 C might be at a 30 weight, 40 weight, 50 weight, whatever it is they decide. I will say though, that most of those non-detergent oils do possess some type of anti-foam or anti-foam characteristic to help with that. So again, from what I've seen and my experience, the discussions I've had, the shows I've done, more often than not, they tend to side on an additized oil, something like PennGrade1, that will afford them anti-wear protection as well as a great detergency package. So really is dependent on the application and dependent on the end user.
All right, perfect. Ken, we have Troy Kellis asking a question about specific oils that he should be using. He lives a little bit further north in Oregon, and during the winter, he changes to a lighter 10W30. During the summer, he uses a heavier 20W50. And should he be worried about doing that? His vehicle is a 1985 C20 8600 GVW.
Yeah. Again, one thing to remember, any multi-grade that's identified with the W identifies that oil as being best suited for cold ambient temperature startup conditions. Now, many individuals that run their vehicles year-round, let's say with a heavier, more viscous oil like the 20W50, can still utilize that given viscosity because of the W, because it is a true multi-grade designed for cold ambient temperature startup conditions. However, the much lighter 10W30 would be even better suited for the colder ambient temperature startups. So as long as the bearing clearance and ambient temperature support it, you're going to get better pumpability or flowability in the very cold ambient climate. Like you said, in Oregon, where this gentleman lives, running a 10W30 versus a 20W50, even though the 20W50 is still designed as a multi-grade suitable for winter use service. Okay, so actually the practice that, you know, the procedure and the practice that he's doing now is actually ideal for when the weather turns and stays cold. He's going to get better flowability with the lighter multi-grade than the heavier one. Now,
Sure.
Again, I'm old school. I like running the heavier, more viscous oil as long as the bearing clearance and ambient temperature support it. So would he get better protection, better film strength, better shear stability with the heavier 2050 in the summer versus a 10W30? Absolutely. Okay.
Perfect. Now, Troy also asked about using PennGrade1 Nitro 70W. Can that be used as a engine assembly lube?
Ooh, no. And my reason for that is simple. The Nitro 70 contains higher levels of anti-wear chemistry. Remember what I said earlier about having too much anti-wear in your brake-in oil. Any qualified engine builder will tell you that they expect some supportive wear to occur during that initial run-in phase. And it's actually that supportive wear that can help facilitate ring seating. By having too much anti-wear in the Nitro 70, that may actually prevent that from occurring. Not to mention, it's such a viscous oil. It's so heavy that it may not even be an option for you. That's why universally and for many, many decades, engine builders still prefer a 30 weight or an SAE 30 viscosity to run in not only their gasoline-fueled engines, but also diesel-fueled engines. A lot of end users don't realize that our PennGrade1 brake-in oil SAE 30 can be used to brake in diesel engines as well. So it's a great product.
Excellent. Troy, thanks for that question. Claude Townsend is asking if you can expand on the new oil classification that's currently out and the use, the impact, and the pros and cons of those newer classifications.
Yeah, again, you're talking full synthetic across the board, There are manufacturers that still offer synthetic blends. You're getting into the, okay, how often should I change my oil? Specifically the drain interval, which is all OEM driven anyways. By the way, the general rule of thumb when it comes to ODI or oil drain interval is if you are consistently running a conventional mineral-based oil, change your oil every 3,000 miles or once a year. In a more modern application, if you're running a synthetic blend, I typically recommend between 3,000 and 5,000 mile drain interval. And if your late model vehicle, if you're running a full synthetic, I typically recommend 500 to 7,500 miles. But again, oil drain interval is largely dependent on how and when you use the application. But when you're talking about modern day API SM Plus rated oils, okay, you see the engines that have much tighter clearances. Again, everything is fuel economy driven. The 10W30 of yesteryear has been replaced with 520 and 5W30 as the one size fits all viscosity. 0W20 is a very popular OEM recommended viscosity. API has already adopted 0W16, and now you have some original equipment manufacturers that have already started to field evaluate 0W8. And I don't know if any of you have ever literally poured a 0W20 out of its quart bottle, but it is almost like water. Okay, so that's where the industry is going. Not to mention today's oils have very strict specifications, much more than any of the oils of yesterday. So there's a lot that goes into blending and formulating oils of today than in the past.
Excellent. Ken, we've got a question about the ideal oil temperature and where it should be measured. And this person's asking if you could address that question on both the non-external and external oil cooler.
Yeah, I love this question. And anytime you can incorporate an oil cool is always a benefit if you are running PennGrade1 high performance oils. You have to remember that the PennGrade1 high performance oils are mostly conventional mineral based. If you utilize one of our monogrades, you're dealing with a product that is 100% conventional mineral based. So again, an oil cooler is always a benefit. Now, when it comes to extreme operating temperatures, because we're often asked this, I'm comfortable with PennGrade1 being used. And this is where that partial synthetic component really comes to play and helps. You know, we have known, and again, this is based on decades of feedback that we've received on PennGrade1 in those high revving, high horsepower, high operating temperature engines. I'm typically comfortable if you are seeing 300 degrees Fahrenheit on a continuous basis. I start to become concerned if you are at the 350 Fahrenheit range on a continuous basis, not necessarily on an intermittent basis, but on a continuous basis. There are air-cooled engines. One in particular that comes to mind is Corvair, that are notorious for running well above 350 degrees Fahrenheit on a continuous basis. Yet those that utilize the PennGrade1 high performance oil 20W50 in those engines still enjoy 3,000 mile oil drains or once a year, whichever comes first. So again, because of that unique Pennsylvania grade base cut, because of the fact that it affords that high thermal stability, because we incorporate that very small percentage of synthetic component, you're really, again, kind of getting the best of both worlds. You're getting the protection from the tenacious clingability and all that I just mentioned. So to pin me down with a Fahrenheit, I would say 350 on a intermittent basis between 300 and 350 on a continuous basis, I'm okay with, as long as you adhere to that more frequent, carefully selected interval. And that's really the best I can answer that. So,
no, excellent. Ken, we kind of have maybe like 2 last questions here, and I think we've pretty much covered the other ones in some form of or another. But we have Mark who's asking about, how much does an crude oil stock impact, a final oil's performance versus the final formulation? What's ultimately more important? And, I know a lot of people operate under the assumption an oil is an oil, as long as you're using something and changing it regularly. Is that the truth, or, are there some key differences?
Obviously, when you factor in the different base oil groups and what is being used, you can't formulate an engine oil that is expected to last, 7,500 miles, 10,000 mile drains with Group 1 quality oil. However, that group oil quality of Pennsylvania grade base stock, that unique cut that's been utilized in the original green oil for over half a century, is what makes the product what it is. And quite frankly, what gives it its unique performance and proven protection ability. So it has everything to do with PennGrade1 high performance. It's when you get into the more modern licensed oils, the longer expected drain intervals, where you expect that quality of the base oil to obviously, whether it be Group 2, Group 3, full PAO, polyalpha olefin, full synthetic quality, would certainly lend to the better volatility that I discussed earlier, the better high temperature stability, the better low temperature fluidity and pumpability. All that's afforded to you by a better base oil quality laden lubricant.
Right. No, absolutely. Well put. Well, Ken, like I said, I think we've gone through the questions, that have been on there and covered all the topics that have kind of been asked through this session. So I really appreciate, on behalf of Engine Builder, I appreciate your time today to sit down with the folks on our call, and everyone who joined us today. I appreciate you guys being part of this. Please, you can follow Engine Builder as well as PennGrade on most of the bigger social media platforms. Get more content on each the PennGrade website as well as the Engine Builder website. And like I said earlier, this session will be on YouTube and available to rewatch or catch the end if you had to drop off early. And one last note, PennGrade does have a $10 mail-in rebate happening right now for the month of May. So make sure you go out, buy some PennGrade oil, and you guys can use that mail-in rebate and save $10. So again, Ken, thank you very much for being with us today, and thanks everyone for participating.
Well, thank you, Greg. On behalf of Mike Prodiger, DA Lubricant Company owner, John Knoll, Scott Keir, all my friends and colleagues at DA, PennGrade, PennGrade1 Lubricants, and especially a shout out to my good friend Nick Dixon, the very heart and soul of PennGrade1 High Performance. Thank you for this opportunity. And until next time, Greg, we'll see you at a show, and you take care and be safe, my friend.
Yeah, likewise. Yeah, we all can't wait to get back out there in person and do it the right way. So.
Yes, sir.
Absolutely. Well, thanks again, Ken. Thanks, everybody. Have a great afternoon.
Thank you.